everyone, I am Bharat Singla and welcome to Learn Competitive Programming with CodeChef. If you desperately want to master competitive programming and get your hands dirty in data structures and algorithms, then this is a one-stop destination for you. Every week, we upload problem explanation from CodeChef's contests, conceptual videos on various programming paradigms, and also conduct live interactive sessions. But before we start off, here's a reminder for you to hit the subscribe button if you haven't yet already. Great. Now that you have subscribed, let's get started. So this is the problem statement. So we'll be given a list of n integers. Now a prefix is nothing but a subarray, or in other words a part of an array that starts from the first element itself and can go up till any point. Like the prefix till the third element are these three elements. Fine. And every prefix has a corresponding prefix sum with it, and a prefix sum is nothing but the sum of all elements in a prefix. So prefix sum till the third element would be 9 plus minus 7 plus minus 4, and this is nothing but minus 2. Fine. So the sum is minus 2. Fine. Now these are the two definitions, and a list of length n has n possible prefixes. Yeah, till the first, till the second, till the third, till the fourth. So if n is 4, there are 4 possible prefixes, and there are n corresponding prefix sums as well. So n prefixes and n corresponding prefixes sums. Fine. Now our goal is to ensure that no prefix sum is negative. So for every possible prefix, the prefix sum should be greater than or equal to 0. Fine. Like in this case, negative 2, so it is not desired. So to counter this, so to achieve this, we can flip the signs of some of the negative values in the list. Like like here, if I convert minus 7 to positive 7, or I can convert minus 4 to positive 4. So here if I make this plus 4, so now the sum becomes 9 minus 7 to 2 plus 4, that is 6. So now the sum becomes plus 6. Fine. And now we are ending up with a positive prefix sum. Now our goal is to identify the minimum number of values in the list whose sign needs to be flipped. Fine, such that no prefix sum is negative. Now here note that the sum till the first element, so the prefix sum ending at the first element is 9, so it is positive. Till minus 7 it's 2, so again positive. Here we have inverted the sign of minus 4 and now it's plus 4. So here the sum we saw was plus 6, again positive. And till 6 also the sum becomes plus 12, that is positive. So here by flipping the sign of only one element, we ended up with all the prefixes having a positive sum. So in this case, answer comes out to be 1, since we only converted one element. And so we can say that for this array, the answer is 1, and the answer will be different for different arrays. We'll be given a few arrays and we'll be need to find the minimum number of values whose sign needs to be toggled so that every prefix sum is positive. So this was the problem statement, and now that we are comfortable with it, let us move on to the solution. So the main idea that we are going to use in the solution is that for any negative sum prefix, let's say ending at I, we must change I or any negative element on the left of I to positive. Fine. Now why on the left of I? Now this is because, let's say if I take the prefix ending at 4. Fine. So this is the sum till the prefix ending at 4 is only dependent on the elements that are the first element, the second element, the third element, and the fourth element, right? It is not dependent on the sixth element or the seventh element that is on the right of 4. Fine. So if the prefix until 4 is negative, then to make it positive, I should either change the first element to positive or the second element to positive, considering that they are negative, or the third or the fourth. Fine. There's no point changing the fifth or the sixth element. Fine. So this is the first observation. And which number should we choose? Well, the one with the highest magnitude. So let's say if I have choice between two elements. So if I have, let's say, minus 5 and minus 10. So which element should I convert to positive? Well, I should take negative 10, because then it would become positive 10, and that is giving us a larger value than plus 5. Fine. So we should take the one with the, in other words, the highest absolute value, so that it is beneficial and it contributes to a greater positive sum. Fine. So these are the two observations, and they are basically the only observations required. And now to understand this approach better, let us dry run it on the second test case of the problem. And in other words, you can say that dry run is nothing but the simulation of the process. Fine. So to understand the approach better, let us do a dry run on the second test case. So now let us dry run our approach on the second test case, and this was the array that you are given. So first I'll take the prefix till minus 15. Its sum is minus 15. So we need to convert this element or something on its left to positive. Well, here we are only given one element. So this will be plus 15. And I'll just mark this as well. And also recalculate the sums. So it becomes plus 15 now. Till minus 12, the sum is 3. So it's positive, so we can move on. Then till minus 10, the sum is minus 7 and that is negative. So we need to convert one element at least. Now here it's always beneficial to take minus 12 because that when we make it to plus 12 will give us a larger value than plus 10. So that's why I'll convert this element and mark it as well and just recalculate the sums. So this becomes 27 and this becomes 17 now. Fine. Then till minus 13, the sum is 4. We can move on. Then minus 2, it is 2. Again, it's positive. Then till minus 3, it becomes minus 1. Now again a negative prefix. So the element that we are going to convert is minus 13. Marking it as well and recalculating the sum. So this becomes 30 now. This becomes 28 and this becomes 25. Fine. Then, and just as a side note, I just wanted to tell that if you're thinking that how is he able to calculate the sum so fast, well, I'm just using the simple trick that the sum till I is nothing but the sum till I minus 1 plus the ith element. Fine. So next we go to minus 17. Here the sum now becomes 8 and we'll move to minus 19. The sum now becomes minus 11, so negative, and the element that's the best to convert is minus 19. Marking it as well and just recalculating the sums. So now this becomes 27 till minus 5, the sum becomes 22 until minus 9, the sum is 30 plus 30. Yeah, so here we have finished our iterations and here you can see that all prefix sums are positive. So yes, we have accomplished the desired state and the number of operations we took were 4. So the answer for this test case is 4. Now you can also verify that we cannot achieve something better than this. And just before we wind up the video, I would just like to just leave a side note here that I'm leaving the first test case as well as the third test case as an exercise for you. You can use the same approach given here to find the answer, but I'll still punch down the test cases as well as the answers in the comment section so you can refer to them as well. So this wraps up the video, guys. So thanks for watching, guys. If you liked the video or just learned something new, don't forget to hit the like button and leave down a comment if you have any queries or suggestion or some feedback. You can also join our Telegram channel. The link is in the description box below to stay even more updated. I am Bharat Singla signing off for now and I'll see you next time.